Hi, I'm Steve Carroll. I'm the dev manager of the Visual C++ team, and with me as always is
Gabriel, program manager on the Visual C++ team.
And welcome to the latest episode of Going Native. Today we're going to talk about our refactoring tools in Visual Studio 2015.
Some of you might have seen some of these features on the VC++ subseries, sorry, the VC++ Byte subseries of Going Native, but there are new features that you may not have seen during the series, and the ones that you have been improved as well, so you can look forward to checking out how to use those features.
So today, ironically, we're actually interviewing Gabriel Ha, program manager in the Visual C++ team.
Hello, everyone.
Who is actually the feature PM who worked on a lot of these refactoring. So today we're going to show you the new tools. Do you want to tell us a little bit about kind of the design point that we were going for? Refactoring tools are not a completely new concept.
Of course. Refactoring, not a new thing. C# has been doing it for years. There are tools that do it for C++. And when we set about to design our refactoring story for Visual C++, we had two design principles in mind. First, correctness, and second, reinforcing good coding practices. Now, on the topic of correctness, there are probably a good number of people out there who want to ask us, what took you so long to come up with a C++ refactoring story? Because there are tools that have been doing it for a while. They seem to be pretty good. Refactoring is an important workflow. Why would you not support it? And the thing you have to understand is the precedent of Visual C++ code generation tools is that if we put code in a customer's code base, that code needs to be correct, error-free, and that their code still builds and compiles. And because C++ is such a complex language, when we were first prototyping things like our rename tool, for example, we realized that there were scenarios in which we could not get things 100% correct. And it was unthinkable that we would ship a tool that sometimes puts uncompilable code in a customer's code base. So when we relayed this feedback to customers, their response was, having something that can get me 50 to 80% of the way there is better than having nothing at all. We understand that C++ is complex, but we're happy to pick up on that other 20% that it couldn't do, because ultimately, at the end of the day, it's saving me time, and that's why I would use the refactoring tool in the first place. Now, don't get me wrong, we still try to get things as correct as possible with Visual Studio's infrastructure, with the database. We have the ability to get things as correct as we possibly can within the confines of the complexity of C++. So, it's a bit of a paradigm shift for us to move away from that. In a way, C++ refactoring is an exception amongst other code generation tools in the product. But as long as it works for basic cases, as long as customers aren't surprised when it can't 100% handle more complex scenarios, we're happy, and hopefully you guys will be as well. On the second topic, reinforcing good coding practices, we have the technology to help you with things like, for example, it's good coding practice in C++ if you have some functions in a header and the corresponding functions in a CPP to keep those functions in the same relative order. And so we can do things like, if you're generating a function's counterpart from, say, the header file, we can look at the context around the header file and then look in the CPP and have a good idea of where that function's counterpart is supposed to go. So, in a way, you get that for free and reinforce good coding practices as well.
Cool. Let's jump into the demo.
All right, so let's get right into our demo of all our refactoring features in Visual Studio 2015, at least at the time of this recording. So what I have here is a modified MFC project, and of course it's been modified so that it'll make it easier for me to show off all the refactoring features. Now, the build that I'm using is an internal build at Microsoft, so these bits are not publicly available yet, so some of the refactoring features have been modified since Visual Studio 2015 Preview. So while these particular bits may not be publicly available, you can look forward to seeing these features in a more polished state that'll be more representative of what you can expect in RC and RTM. So let's get started with the most important refactoring feature, rename. Over here I've got these two functions called serialize. One is an overloaded function of the other, and suppose that I want to rename both of these functions to something else. So I'm going to right click here, and for those of you who have played around with Preview or the CTPs, you'll notice that the refactoring submenu inside the right click menu, or context menu as we call it, is missing. It's not there anymore. And what we've done is we've consolidated what would have been quick fixes and refactorings into something called quick actions, which you can activate with a shortcut Control Dot. Now, rename is so important that we decided it should get its own position directly on the context menu. So here we go, here's rename. And here's an example of the first set of changes that you'll just have to anticipate getting on your hands. But this symbol disambiguation dialog is telling me that there are two serialized functions. And in this case, I do want to select all of them. So I'm gonna hit OK. And let's say I wanted to call it do serialize. Now, I want to take some time to briefly go over what this term confirmed means. This is C++ code. There might be some symbols or artifacts or macros inside my code that might make it difficult for the rename refactor tool to get everything 100% correct. But if I don't have anything too weird inside of my code, especially if I were just renaming a local variable, there's a good chance that the tool can figure out exactly what to rename and what not to. And so if we proceed from here, we're going to see a preview window, which I'll likely want to see because this is a function that's potentially used in a lot of places and I might want to make sure. But in the event that you're just making a local change, you might check this box and say, skip the preview dialog if everything is confirmed, and then you can just hit apply and you won't see it. And this setting will be saved for the next time that you choose to use the rename dialog, so you won't have to keep checking it if you're confident that you don't need to see a preview dialog. So we've also restructured some things around this top part of the preview window, and let me just explain real quick how this is structured. So there are 4 categories of entries inside this window. The first 2 are essentially the confirmed entries. That's the first set of symbols, and there are 2 of them, of course, because I have 2 different overloads. The next category is unconfirmed references, and these could happen if you have malformed code or code with a lot of squiggles, so it's harder for IntelliSense to glean the correct intention for a piece of code in that context. Then you also have an entry for comments and strings. The node right under the top level node is the document, so there might be multiple entries under one of these documents, and in order to see the specific entry, you'd actually need to click on the entry itself. If you click on the document, you just see the beginning of the document. But for things like demo project doc.cpp, where I have multiple entries, this is why we have this node. So let's say I'm fairly confident that all the confirmed entries are correct, and maybe I want to search through these comments a bit. This is serialized with a reference to carchive AR. That looks correct, so I'm going to check that one. This one also looks good. In fact, I'm pretty sure all of them are probably fine. Let's say I'm also equally confident about the strings that I'm using. So let's say I'm happy with these changes, and I'm just going to hit apply. And if you want to see exactly what happened, you can always look at the output window, change this to Visual C++ Refactoring, and see everything that happened. So here are all the entries. Take a look at that, and if I build this project, let's just see that it still compiles. Hey, look at that, looks like we're good. Let's move on to our second feature, extract function. Actually, this is convenient. I happen to open the document that I needed. Suppose I have some code here that I'd like to extract into its own function, and how I'll do that is I will select the code, and again, I'm typing in Control Dot here just to activate that quick actions light bulb menu a little faster, and I'm going to say extract function. This particular extracted function is void, and the only thing that it requires is the time span symbol, as that is used outside of the function here. I'm going to click OK, and it's going to create that function below my current function, so here we go. And notice that it has been put in the same scope as the function that it was extracted from. I'm personally aware of other implementations of this refactoring feature that allow you to extract as a free function, and if this is something you'd really like to see, let us know. But in the event that you do want it as the same scope, you'll notice that if I right-click and do a go to definition, we have actually created the for declaration in the header file positioned appropriately relative to neighboring functions. And if you already know where you plan to put this function, like let's say you're going to put it at the end, you can just use the Alt down and Alt up keys to move that around where you want. And as I'm doing this demo, I'm now realizing that it might be useful to have a feature that moves around the definition counterpart when you move around the declaration. Let me know your thoughts on that, if it's a nice to have versus a I do this all the time and I desperately want this feature. Here's an extract function example where you're not extracting a void function. Suppose I want to extract a piece of code that's supposed to return an integer. You notice that getHours returns a macro long in this case. So if I extract this code, I'm gonna hit control dot, activate extract function, that's what we'll get. The extract function detects that getHours is a const operation, so it puts that in for you. So that's nice. And here we go with the new function again. I'll just compile this and show that everything works. There we go. I'm going to do undo one more time, and I'm just going to show that extract function has a limited amount of error checking. For example, if I were to now extract this, it'll tell me that it couldn't extract it because hours is used below the code. So again, it has some limited error checking such as this. We wanted the feature to be smart, but not too smart, because I'm sure there's hundreds of scenarios with their own unique nuances that you could find yourself using this feature with C++. Moving on, our next set of features have been previously showcased in VC++ Bytes, but they are not without their improvements and bug fixes. So first up is implement pure virtuals. This is useful when you have a class that is inheriting from constructs containing pure virtual functions. It helps stub out those definitions for you so that you can instantiate that class. So to use the tool, you would come to the class definition and right-click Quick Actions, and then you have implement all pure virtuals for that class. And what will happen is there are 4 pure virtual functions. It's going to stub each of them out, and the improvement that we've made is code peek comes up to show you what happened in the CPP. Again, following good coding practices, we provide the override keyword for the 4 declarations, and then we create the definitions in the CPP file of the same name. And if this file does not exist, we will create that file on disk for you. I'm going to exit out of that for now, and you'll see that there are comment delimiters indicating which base construct these functions came from for your reference. And if I undo this operation, it will remove everything, including from the header file, as well as in the CPP as well. If you just want to implement pure virtuals from a particular base, you can come to the base in that definition, say quick actions, and it'll change to implement pure virtuals just for that base. So you'll just get those functions, as you can see here. Now let's say the next thing you wanted to do in this project was add a constructor that actually takes in some variables. So let's just type in c/doc here, and let's say it takes in some parameters. You'll notice this green squiggle comes up, and if you hover over it, you'll get an option to create the definition of that constructor in the CPP. Code peek comes up to alleviate the context switching. We're making changes in another part of the project, but you don't have to leave your current context. So this is the create declaration definition feature. The feature also includes the functionality to stub out multiple definitions at a time. So if you look at each of the green squiggled functions here, these are functions that don't have a counterpart in the CPP. I'll just switch over there real quick to show you that. So what you can do is you can just select everything. It doesn't even have to be precise. Right-click, say quick actions, and then create declaration definition. And the reason that code peek doesn't show up is that there are some cases in which the definitions could be placed in different files, and because we don't have a solution for that yet, you can just see everything in the output window. So if we double click here, you can see that those functions got created, that the constructor and destructor did not get duplicated, and that all the functions are in order. So here we're back in the header file. Suppose we wanted to inline all of these functions. We don't want them in the CPP for whatever reason. You can, again, just select the code that you need, right-click, quick actions, and say move definition. And that's going to move everything in line. In this case, if we look at the CPP, you'll notice that it's empty. And we can go back if you want. Suppose we just wanted to select these functions to put back in the CPP. move definition, and there we go. Notice that the 4 declarations are still preserved, but the definitions have been moved to the CPP. And so there's our throwback to previous VC++ Bytes episodes. You can still enjoy these features. And last but not least, we have the convert to raw string literal feature. Raw string literals is a feature introduced in C++11, and essentially it just makes some strings with escape sequences a lot easier to read. So these are the 6 escape sequences that the feature supports. So if you'll right-click here, so you convert to raw string literal, you have new line, tab, single quote, double quote, question mark, and backslash. And here's an example of that I like to use here. This is the actual string and then converted to raw string literals. Just, reads a lot more easily without the extra stuff. Here's a regex expression where your first question might be, how many backslashes does this thing actually have? And if you do a convert to raw string literal, that's what you'll get, so it's a little easier to see. Now, first thing to mention, there is no option to convert back to a non-raw string literal. That is just the undo key. That's pretty much all you can do in that case. And then in cases where you might have an escape sequence that is unrecognized, for example, I'm just going to make one up like \p. That's not supposed to mean anything. This is what you'll get. The feature will tell you what the first unrecognized escape sequence is and that it can't convert it. It has a similar behavior with escape sequences that are valid but have no textual implications, like the null character, for example. So same thing's going to happen here. Hopefully that's understandable to you guys. There's also currently not an option to do multiple strings at once. If that's a feature you guys would like to see, let us know. That is convert to raw string literal. Hopefully it makes your code easier to read. Before we wrap up, I'm here with some of the developers of the refactoring experience in Visual Studio 2015. Thank you for watching today's episode, for trying out the features, and for leaving us your feedback. Thanks for watching. That was our episode for today. And again, this is code that is still in flight, so definitely leave us your feedback, how we can make it better, especially on customizability points that you guys particularly care about. Definitely let us know in the comments what you guys think and what you guys want to see.
Thanks for joining us for another episode of Going Native, and happy holidays, and I'll see you next year.